Hi everyone, I'm Olivia, and today I'm trying to introduce to you the 2014 intensive exam prep course for the IB examination, particularly for chemistry today. And we are going to have a 14-hour intensive course to prepare you for your IB exams. In this course, there are two main focuses. The first one is to familiarize yourself and highlight the key topics in the whole entire syllabus. And the second thing is to help you practice a lot of the exam questions, so you will familiar with the exam structure. And also you may be aware of the new trend in the exam where they are trying to test you with a lot of the unfamiliar context but the same chemistry knowledge. So what we'll do is not only use the past paper question, but we also design new questions so that you will be able to see some new examples, and also you wouldn't be so scared when you see the actual exam, a lot of the things that you have not seen before, but in fact they're really asking the same thing. So today I will do a demo, particularly on topic 6, the kinetics, how the course would be like. So kinetics ultimately is to answer the question how fast a chemical reaction is. And the rate of reaction is the increase in the concentration of product over time, or the decrease in the concentration of reactants over time. So the quicker, the faster the product is produced, the faster the rate of reactions will be. And the second things we will learn is the different factors that will affect the rate of reactions. And there are, if you don't remember, I'll remind you, these are the different factors. So the first ones are the concentration of reactants, the pressure or the surface area of reactants. Now, why do I put all of these together on the same line? Very important, because if the reactants are in different phase, you have to answer them accordingly. Only aqueous solutions will have a concentration, while gaseous state reactants will consider the pressure. And finally, solid state reactants will consider the surface area. If you match the wrong factors to the wrong phase of product, you will not get the mark. And secondly is the particle size. And also temperature and catalyst will also affect the rate of reaction. Now what we need to know is how to explain why these factors will affect the rate of reaction. The key thing we have to always remember is the collision theory. Whenever you see kinetic questions about how fast the reaction is, rate of reaction, always link the concept of collision theory. Collision theory tells us that a reaction will occur when particles collide under two specific circumstances. First, you need to have sufficient energy, which is the activation energy. That is the minimum amount of energy required for them to have effective collision. Secondly is the orientations. When they collide, they need to collide in the right positions. Otherwise, no reaction will happen. And we'll use this theory to explain why these factors will affect the rate of reaction. Now, finally, we also have a very important diagram. If you recall this diagram, that's the Maxwell-Boltzmann distribution curve. This is used to evaluate or explain how temperature and activation energy will affect the rate of reaction. So you need to be able to sketch this diagram properly to explain the effect of temperature and catalyst. Okay, so that's everything we have learned for standard level. Then we move on to the higher level material. So for higher level, ultimately, we are learning how to quantitatively evaluate all those factors and their effect on the rate of reactions. So the first things that we do is the rate expressions. So the rate expression quantitatively evaluate how the concentration of reactant is going to affect the rate of reaction. That's all the first order, zeroth order, second order comes into place. And this is the rate expressions. Rate equals to the rate constant K and then the concentration of the different reactants. Now, apart from finding out the rate expressions given some data, we also need to learn how to analyze them graphically. There are two types of graph that is very important. One is the concentration time graph. The other one is the rate concentration graph. They have different appearance. The shape will indicate what kind of order is the reactants with respect to. And another thing very important is the mechanisms of the reaction. That's where we learn under this topic. It's related to the rate expression. If you don't remember exactly how they're related, stay tuned. We'll go into more depth. And then finally, the last part is how temperature and activation energy quantitatively affect the rate of the reactions. Now you may see here in the rate expressions, there's only the concentration of reactants. There's no room to show how temperature change or the activation energy change will change the rate of reactions. But we see here, there's the rate constant. So ultimately, the relationship between temperature and activation energy is on the rate constant, K. So Arrhenius equation is the equation where we capture this relationship. And for your syllabus, you don't have to memorize the equation. All you need to do is to know how to graphically analyze and get the calculate the activation energy.